What's happening, everybody? We're going to talk about section 3.2, solving multi-step equations, and the objective by the end of the class is that you will be able to indeed solve multi-step equations. I have to find out the right spot to touch my board to get my tools to show up. There we go. We're working on it. We're getting there, people. We are getting there. We're going to go purple. And our first example is solve 3a plus 6 plus a equals 90. So, I'm going to take a little look here. Looks a little different than last section. We got a little bit more going on. First thing I notice is two different terms on the left side have the variable a. So, when I see this, my first thought is, well, I need to find out what a equals, so I got to get these together. So, a has a 1 in front of it. You can put it there if you want. You don't need it. If I've got 3 A's and I've got 1A, and they are on the same side, I'm going to just do exactly what I see, which is 3A plus 1A. So 4A plus 6 equals 90. That's called something you've probably heard of before, combining like terms. So I've done the combining like terms. What I've now got is a traditional two-step equation, which we did last section. So I'm just going to kind of buzz through this and hopefully not waste your time because you're feeling pretty good about it. But if you're not, pause it, try it, talk to me, ask questions. All right, so 4a plus 6, first step, take away the 6. 6 is canceled. Bring down the 4a. Bring down the equal sign. Bring down 90 minus 6, which is 84. Next, I see a is being multiplied by 4, indicates to me divide by 4. The 4's cross out and become a single a. A now equals, hopefully, 21. Again, we're going to do a quick check in the original. Quick check in the original. So 3 times 21. Hopefully, I don't mess things up over the side of the board here. Plus 6 plus 21 equals 90, question mark. 63 plus 6 plus 21. 69 plus 21. Is that 90? I hope so. I believe it is. I believe it is. Check works. We got the right answer. Great job, y'all. A little bit of a word problem. Give you a second to read it, even though you can pause it. So I don't know why I'm doing that. I'm actually just taking a drink of water. You need to build a rectangular pen in your backyard for your dog. One side of the pen will be against the house. So I'm going to start drawing a little picture here. I'm going to get the house going. So here's my house. This is the wall of the house. And we're building a rectangular pen against the house. One side of the pen's against the house. Perfect. Two sides of the pen have a length of x feet. So two of these sides are the same. That would be this side and this side. And I want to put over here the x equals feet. Excuse me. And the width of the pen is going to be 25 feet. So we've got all of this labeled. Beautiful. It says, what is the greatest length the pen can be if you have 63 feet of fencing? Well, that means I've got a total of 63 feet for all of these sides, for this side, and this side. So, I got to add them all up. I got an x and an x here. Combine that is 2x, and I got a 25 here. So we're going to add that on. 2x plus 25, we need this to be equal to 63 feet, which is our total number of feet for the fence. Two-step equation, although, yeah, it's a two-step. I kind of did one step already by combining the x's. So technically, I could have started with x plus 25, but that's the same thing as that. So we know how to solve this, hopefully, but if you do not, that's all right. We're going to provide plenty of opportunities to go over this, and all you got to do is reach out, y'all. So we're going to take away 25, because that's the opposite of adding 25. 2x equals, what's that, 38? 2 times x, opposite is divide. Divide by 2, divide by 2. X equals 19. 19 what? 19 feet, which is the greatest length, greatest length the pen can be. So these two sides are 19. Quick check, 19 plus 19 plus 25. 38 plus 25 is 63, which is our total feet of fencing. We are good to go. Got something a little different here. You've got to solve this equation again. I don't see two variables. I don't see a normal two-step equation. Kind of looks like a two-step equation, but we've got the parentheses. So we've got 2 parentheses x minus 3 equals 8. Two things being next to each other indicate multiplication, right? So I'm going to show you 2 ways to do this. Step 1, in the first way, is using distribution. Distribution is going to allow you to multiply something on the outside of parentheses to all of the things on the inside of the parentheses. So I'll show you what that looks like. You go with one of these things. You've probably seen this before. So I'm going to do 2 times x, which is 2x. I'm going to do 2 times the 3, which is 6. And I'm also going to bring down the minus sign. So 2x minus 6 equals 8. From there, quick solve, plus 6, plus 6. Cancel that out. 2x equals 14. Divide by 2, divide by 2. X equals 7. We'll check it at the end. Hopefully we get the same answer both ways. Here's a different way. Option number 2. I'm going to change color so you know it's a different method here. And we don't get El Confuso. So 2 would be, I don't know, I guess kind of like the reverse order of operations, just like you normally would solve an equation. So how does that look? Well, we got 2x minus 3 equals 8. What's happening between the 2 and the parentheses? I want to get rid of that 2. In the previous example here, I distributed it to get 2x minus 6. Well, here I'm thinking, what's the opposite of multiplication? It's division. I can just divide this 2 from both sides. And the reason I can do that is because that 2 is part of both the x and the minus 3. That cancels out the parentheses, cancels out the 2's, all that gives you 4. How do you get rid of minus 3 with a plus 3? We get the same answer both ways. Chances are I did it 2 different ways, both same answer. Most likely got the right answer. Quick check is easy enough. 2, 7 minus 3 equals 8. This is my check. And I got 2 times what's 7 minus 3? It is 4. 8 does equal 8 indeed. Whew. I'm tired, y'all. But we're going to do this. We got this. Okay. I feel like there's another part to this slide. Let me see. There is. So method 1 is finding common denominators. This one looks a little scary to a lot of people. To be honest with you, it's not that scary. If I look on the left, I got 2 different terms. Whoa. 2 different terms. Got to re-grab my pen here. If I could do this. There we go. Pen tool is working. That's good. So I got my pen tool up, so we're back in business. The good news is both of these terms have a variable in them. That means at some point we should be able to combine them. So I look at the 2 fractions, and I want to, I'm on the wrong slide. We're going to go back, hopefully. Erase that. We're going to go back a slide. We're going to go forward a bunch of slides and screw this all up, but we're going to move through it, babies. We got this. Okay, am I on the original one now? I think so. All right, I'm back in business. No, I'm not. Okay, back in business. Sorry about all that. Everything's changing. Why is it happening? Okay, so finding common denominators, like I was talking about before. Sorry about all that. 2 and 5. Finding common denominator in this case, best way to do it, or quickest way to do it, is to multiply the two denominators. 2 times 5 is 10. So I want to change them both into 10s. 3x over 2, I want to make that a 10. And I want to make x over 5, I want to make that a 10 down there. So how do I get from 2 to 10? I multiply by 5, so it's the same thing. Multiply by 5, and we have 15x over 10. Here, multiply by 2, and we get 2x over 10. So these are my two new terms that I'm going to substitute in. So I've got 15x over 10 plus 2x over 10 equals 17. All right, let's see. Well, I can now add those fractions. They have the same denominator, so we just add up the top. So 15x plus 2x, 17x over 10. So I don't know if we've encountered this yet, so I'm going to address it. What we've got now is we've got a fraction times x. And I think we've done this before. The best way to get rid of a fraction when it's being multiplied, if you want to cancel it out and make it a 1, is to multiply by the reciprocal of that fraction. And the reciprocal of a fraction is just when you flip over the fraction. You make the numerator the denominator and vice versa. So what's the reciprocal of 17 over 10? It is 10 over 17. And we are going to multiply by that on both sides. Nice thing about this is the 10's cancel because you got a 10 on top and a 10 on the bottom. 10 divided by 10 is 1. Same with the 17s. We have just a single x left on the left. Over here, you can put a 1 on the bottom. 17 and 17 cancel again because 1 on top, 1 on bottom. 17 divided by 17 is 1. So 10 divided by 1 is 10. That should be our solution. Quick check. 3 times 10 plus over 2, excuse me, plus 10 over 5 equals 17. Let's see. 30 over 2 plus 10 over 5 equals 17. 15 plus 2 equals 17. So that worked out beautifully, even though I had all that trouble with the board. But like I said, y'all, we're kind of winging it. We're making this up as we go. And we're going to be okay when we do that. So here's another method. Step 1. We're trying to multiply to clear the fraction, so we need the common denominator. CD is my common denominator. We found out in the last problem it's 10, right? So once you know that, you're going to multiply the entire equation by 10. Every single part of the equation by 10. Watch the magic that happens. I'm going to show you a quick way to do this now, okay? I think of this as 10 over 1. 10 over 1, I don't need to worry here on the last one because it's just 10 times 17. I jump straight to simplifying by dividing 10 by 2. 10 divided by 2 is 5, and then I just multiply the 5 and the 3x. So this is 15x. Same thing here. 10 divided by 5 is 2. Those cancel, that cancels, we're left with 2x. Now that's a little bit of an advanced method, so if that weirds you out, just email me, let's talk about it. 17x equals 170. Last thing I got that by combining like terms here, 15 plus 2. Last thing I'm going to do is divide by 17. And lo and behold, I get 10 again, which I know is right because I got that on the previous one. So we had two different methods there. It's kind of nice because you pick the one that works for you. I don't have a preference there, to be honest. So, I don't know, you just have at it and see what works. All right, last problem for the section, y'all. We are almost there. I know it's tough, and I know I've made a bunch of mistakes, but hopefully that's cool, y'all. So here, bunch of decimals. Could just do this by handling it normally. I don't really know what the best way to do this problem is. I'm probably just going to do it normally. There are other methods, but to be honest, I would probably just reverse the order of operations and take care of it, business as usual. So subtract 18.65, subtract 18.65. That's going to give you what, 4.2? So I've got 0.6a equals 4.20. And my last step is to divide by the coefficient. Again, it's just the number that's next to the variable, coefficient. And divide by 0.6, divide by 0.6. A is going to equal, handy dandy calculator, 4.20 divided by 0.6. I'm not sure why I needed to do that, because it's actually kind of a simple answer, but lo and behold, it's 7. So check that out, 0.6 times 7 plus 18.65, what's that going to equal? 4.2 plus 18.65, that does indeed equal 22.85. And we know our answer, or at least we have pretty good confidence that our answer is correct. So, again, I thank y'all for joining me. I know that was a little bit of rough at some point. A little bit of rough. That's what I sound like right now. Thanks, y'all. See you next time.